Half a day students, today's lesson is about probability. So when we talk about probability, we're talking about certain events. So a probability is a measure of the likelihood that the event will occur. It's a number between 0 and 1 inclusive. And when I say inclusive, it means the probability could be 0 or it could be 1 also. So probability is usually measured in either a fraction or a decimal. For this section, we'll actually be converting them to decimals. So we can imagine that probability is a line, right? It's between 0 and 1. So let's just mark out some points of this. We have 0, 0.25, 0.5, 0.75, and 1. When p is equal to 0, if your probability is 0, we can also kind of think of it as percent, right? So if I have a 0% chance of something happening, that's where it's impossible. So at the lower end of this spectrum, we have something that's impossible or very unlikely, right? When p is equal to 0.25, I might say that it's just unlikely, right? When p is equal to 0.5, that's where it occurs half the time, right? There's a 50-50 chance. If p is equal to 0.75, I could say that it's quite likely that it'll occur. And then p is equal to 1, that means it's certain. So it's definitely gonna happen. Different outcomes are the possible results. Favorable outcomes are outcomes for an event you wish to happen or whatever you're looking for the probability of, right? And that's how we'll find the theoretical probability. The number of favorable outcomes over total number of outcomes. Let's move on now to an example of this. Again, theoretical probability is the number of favorable over the total number of outcomes. Let's look at rolling a die. So we have a normal 6-sided die with numbers 1 through 6. I know there's 6 possible outcomes if I'm only rolling one die, right? I'm either going to roll a 1, a 2, a 3, a 4, a 5, or a 6. So the probability of me rolling a 1, since there's only one side of a die with the number 1 on it, it'll be 1 over 6, right? The total number of favorable over the total number of outcomes. At 2, there's one side again with 2, and there's 6 sides altogether, so it's also going to be 1 over 6. At 3, it's the same, 1 over 6. At 4, it's also 1 over 6. So I could leave it at that, or maybe I want to actually convert it to decimal to be able to find what a better picture of what the probability is. Putting this into a calculator, I got 0.16 bar, or I might just say, okay, 0.17. And so since all of these single ones, right, where we have 1, 2, 3, 4, same for 5 or 6, they're all going to have the same probability, right, which is 0.17. So I could actually say there's a 17% chance that I'll roll a 3. Now let's look at even number. What is the theoretical probability that I'll roll an even number? So for this one, I have more than one favorable outcome, right? So which one is favorable, right? So if I think of, okay, what are some of the even numbers between 1 and 6? I have 2, 4, and 6. So basically I'm asking, what's the probability that when you roll your die, you'll get either a 2, a 4, or a 6? So again, I know there's still 6 options, but now I have 1, 2, 3 favorable outcomes. So the probability of me rolling an even number is going to equal to 3 over 6, which is just 0.5. So I have a 0.5 probability, so I have a 50% chance, right, of rolling an even number. Same goes for odd numbers. These are just going to be 1, 3, and 5. So this will be, again, 3 over 6, which is 0.5. Different questions that might be asked are, what's the probability that you'll roll at least a 4? So when I say at least a 4, that means I'm either going to roll 4, 5, or 6, right? So that's still, again, 3 over 6, which is half. If I say, okay, what's the probability of rolling less than 3? There's only two numbers less than 3, so it'll be 2 over 6, which is 1/3. So example 1, finding the probability of an event. You toss 2 coins. What is the probability that both are heads? So now there's 2 different coins in play, right? So I'm going to draw a diagram of the different possibilities of outcomes. So one outcome would be, okay, I'm going to just make them different colors. I'll say, okay, the first coin is heads, and the second coin is heads also. Another possible outcome is that the first is heads, and then the second one is tails, right? That could happen. Another possibility is that the first one is heads, or the first one is tails, where I have both tails, right? So I could have one where both are tails, or another one where the first is tails and the second one is heads. So using this, I know that there's 4 possibilities, 4 possible outcomes, but only one favorable, one where both are heads. So my probability is actually going to equal to 1 over 1, 2, 3, 4. The 4 possible outcomes, which is 25% chance. So we have 0.25 as our probability. If I was to ask the probability that one's heads and one's tails, both of these on the right would be possible outcomes. And then for that one, it would be 1/2. Looking at another example of finding probability of an event. In an algebra class, 18 students are 14 years old, 10 are 13. A student is chosen at random. What is the probability that the student is 13 years old? So I'm looking for the probability of the student being 13. So I might look at how many favorable outcomes I have, right? So P is going to equal to number of favorable over total possible outcomes. So the number of favorable outcomes is 10, right? There's 10 kids that I might randomly choose. So I can say, okay, our number of favorable is 10, where they're 13 years old. And now I want to see how many students there are altogether. What are the number of possible outcomes? There's 28 possible students to come from, or to choose from, right? So we have 18 plus 10, the total number of students, and then favorable on the top. So we have 10 over 28. Simplifying this, I'm going to divide them both by 2. That's going to be 5 over 14. Using a calculator, I want to get a better idea of like the percent of this, convert it to a decimal. So putting this into a calculator, I'm able to get 0.357. So I can say, okay, there's about a 36% chance, right? So it's not super likely that I'll choose randomly a 13-year-old. So we talked about theoretical probability, right? Where we look at the number of favorable over the possible number. When we talk about experimental probability, this is not based on what should happen, but instead on what did happen, right? So conducting an actual experiment and then using that to inform your results. And usually when you're doing something like this, you want to have a really big number of tries, right? Of trials, so that it gives a better example of probability. So the formula for experimental probability, we have P is equal to the number of favorable outcomes observed over the total number of trials. Now we're going to get into finding experimental probability. We're going to be using a survey. So a survey is actually a type of experiment. It can be used to make a prediction outside of whatever sample group was used. The pie chart shows the responses of students to a survey asking, what is your favorite subject? If you were to ask a randomly chosen student this question, what is the experimental probability that he or she would say math? So first of all, I know that the formula is number of favorable observed outcomes over total number of trials. So the number of favorable observed outcomes are the number of students who said their favorite subject was math, right? So that'll be 80. So our probability, P, is equal to 80 over the total number of trials. So I want to see how many students they actually asked this question. I can find this total by just adding up all the responses that said the different things, right? The different subjects. So I'll add 80 plus 6 plus 10 plus 8 plus 3. Adding that up, it comes out to 80 plus 6, 86, 96, 104, plus 3 is 107. We have 80 over 107. Finding the equivalent to this, I'll plug it into a calculator. 80 divided by 107 is going to be 0.748. So my probability is 0.748. In other words, if I were to randomly ask a student what their favorite subject was, it's pretty likely there's about a 75% chance that they might answer math, which is not surprising to any of us, right? Yeah. Okay, so that's it for today's lesson. I hope that it wasn't too difficult for you. You're going to be doing an activity where you'll be tossing coins. So you're actually going to conduct an experiment, and you'll have certain answers for the experiment that you conducted and compare it to what the theoretical probability is. So that'll give us, hopefully give us a good idea, even more so, and a better understanding of the differences between experimental and theoretical probability, and how usually when experiments are done to a great extent, so if the more trials you have, the closer it would actually get to the theoretical.